tutorial starts with a song, but it's only a few seconds long.
Computer animation. Computer animation. Computer animation.
Let's get started with animation. Let's create a simple object like a cone. And we give it a color. First of all, a new material. The reason for the new material is that if you stick to the standard Lambert shader, which comes with every default object, and you change that to red, for example, all new objects in the scene will be red. So this is the reason why we go this way. So this is gray here, but it's called a blend now, blend 2, whatever. And we can go to the color here, and now you have a saturation value. It's that one. If you want to keyframe that, it's a little bit hard to do. Right mouse click, there's no keyframe option here. And if you want to type in an expression like equals, sign, whatever, it doesn't accept an expression. It is just not versatile enough for this. So we need another way to create a random color, for example. And the way to go is like this. Let's create a new shader here, a new material, because I like the versatility of Arnolds standard surface shader. It's white. And the shader has a base color, which is currently set to a white with 0.8%. If we reduce this to 0, it doesn't show anything at all. But, and I can render this here, for example, in the viewport, Arnold, I need to make this run now. It says there's no light in the scene. Yeah, obviously not, but we don't need a light for this experiment because we go to emission and we set the emission weight to, well, 1.0. That gives us a strong emission, so it's white now. What we'll do now is create changing colors for this cone. And before we start, I duplicate it, Control D, move it to the side, and I duplicate it again and move it over here. So we have 3 cones now, all with the same color. Now I open the Hypershade window. It's this icon here. It's important for creating interesting connections for shaders. So it sits right here. This is our shader. It's black because it doesn't have a color. It has only an emission. So we can frame this. This was the middle mouse dragging it into this open field here in this gray area here. And what we'll do now is we'll map the base color, it's this entry here, with a random node. And we type in random here, and we get the aiRandom entry here. When we click on it, it lands right here. It has an input color for randomness and an output color, which is this. Down here we have the emission, and here is the emission color. So with this random node, we can map or link the out color to the emission color. So what comes out of that random node goes into the emission color. It's actually 3 values, out color, red, green, and blue. So we need to go into a 3-dimensional, in a vector space, as it's called, and the emission color is 1. So we have this connection now. The colors turn orange, sort of. And when we run the animation, nothing changes. And the reason is that we have this type of randomness here, which is set to 0. If we type in 3 here, we get a different color. Give this a seed 4. If we want to automate it, let's go to float. Float means it can be any number, not just 1, 2, 3, 4, but also 2.007, whatever. And we type in a function here, equals time. So now when we run the animation, we get flickering colors. That's what the random node does. It creates, according to the time number, a new color. So every second we get a new color. Now, how about having different colors for the 3 cones? The 3 cones are 3 objects, and we can do this. Let's reopen the Hypershade window. As I said before, it's this icon here. And we'll create a new node here. First of all, we delete this. And the node is called Jitter. The correct name is aiColourJitter. So it comes into the scene here. So what we need to do is this. We map the out color of the random node to the input of the color jitter. And we map the out color of the color jitter to where we were before, to the emission color. Now our random node is still flickering. It does the same thing as before, but now we can go to the color jitter here, and in the color jitter we can go to, instead of user data, we go to object. So we have color values for each object. And now when we play with this, with these sliders here, we get interesting distributions. And when we run the simulation, we get different colors for all the objects. This is real-time rendering, so to say. That's why we have this anti-aliasing problem here. It's not a real problem, because when we stop the animation, it sits here, and we go to the next frame, it sits here. So this is what I wanted to show you about 2 interesting nodes. One is the aiRandom node, which enables you to create random outputs, not only for color, for position as well, if you like, or rotation, or emission strength of a particle system. So it's a very versatile node. And the color jitter creates jittering colors. And in object mode, it distributes the color randomly to, according to these sliders here, to the objects in the scene. If you have 1000 objects in the scene, they will all have a different color. Bye-bye.